Hello everyone. So this is a PhD interview question. Okay, I think that this is a very important theorem also. So that's why I am making this video. So the question says that give an example of a real valued continuous function which is nowhere differentiable, which is continuous on whole R. That means at each point f is continuous, but for any x f is not differentiable at that point. If you want to construct by hand, it is completely difficult. Okay, you are not able to do it unless you don't know. Okay, this is a special type of construction, and this construction was done by Weierstrass. So the function is called Weirstrass function. Okay, so I'm going to construct this function and explain you in detail that why this is everywhere continuous but nowhere differentiable. Okay, so define phi x equal to mod x for all x belongs to -1 to 1, and extend it periodically on whole R with period 2. That means phi of x plus 2 is phi x. If you want to draw the picture, you will get that, say this is the real line, say this is 0, this is -1, this is 1. So we started with a function phi x which is mod x. That means the function looks like this, and then you periodically extend it. Okay, that means say this is 2, this is 3, means we can extend it this way. So the function is kind of zigzag function. Okay, similarly left hand side also. Okay, this is the function. So clearly phi is continuous on whole R, right? Now define another new function fx equal to summation n equal to 0 to infinity 3 by 4 power n phi of 4 power n x. Okay, since 0 less equal to phi less equal to 1, because phi x is actually mod x, right? And I am periodically extend it on R. So phi is 0 less equal to phi less equal to 1 for any value of x. That means mod fx, okay, so not mod fx, I think so. So then this series n equal to 0 to infinity less equal to say this is summation n equal to 0 to infinity mn. Now we know that summation mn is convergent, and then by Weierstrass M test this series is uniformly convergent. And we know that limit of uniformly convergent sequence, you can take the partial sum of this series. So we know that limit of uniformly convergent sequence is limit of uniformly convergent sequence of continuous function is always continuous, right? So that implies that f is continuous on R. Okay, now this is our required f. So f is continuous on R. Now we need to show f is not differentiable at any point. Okay, to do that, so let fix a real number, say x, and a positive integer, m. Okay, now define delta m equal to plus minus half of 4 power minus m. Okay, where we choose sign so that no integer lies between 4 power mx and 4 power m x plus delta m. So let me explain you this line. See, delta m is explanation. Okay, see, delta m equals to plus minus half 4 power minus m. That means 4 power m delta m is plus minus half, right? That means 4 power mx mod 4 power mx times mod 4 power m plus delta m is half, right? So you will choose the sign in such a way such that there is no integer in between this. Like if you draw the real line, say this one, and say this is 0, this is 1. Suppose you are taking some point here. Okay, you are taking some point 3 by 4 here. Now if you add 3 by 4 plus half, that will gives you 5 by 4, right? Say this one, right? 5 by 4, and 3 by 4 minus half, that will give you 1 by 4. So you will, in this case, you will choose negative sign, because if you choose negative sign, then there will be no integer here. But if you choose positive sign, there will be an integer 1 here, right? So you can easily see that since the difference is half, so either there will be some integer or there will be no integer. So I am choosing the sign depending on whether there will be no integer. Okay, so I will choose that sign depending on the choice, say plus or minus, so that 4 power mx and 4 power mx plus delta m, there will be in between, there is no integer. Okay, alright, I'm choosing in this way. Now define a sequence gamma n equal to phi of 4 power n x plus delta m, where m is the fixed number, right? m is the fixed integer, we already fix it, and we already fixed the real number x. Okay, so here x is that real number and m is that fixed integer. Okay, and n is any arbitrary integer. I am defining a sequence. This minus phi of 4 power nx mod delta m. Okay, now observe, when n greater than m, okay, when n greater than m, 4 power n delta m is basically plus minus half 4 power n minus m. If n greater than m, then it is an even integer. Right? And since phi of x plus 2 is phi x, that will imply that phi of x power 2k is phi x. That means if you add any even integer with x, you will get the same value of phi x. That means phi of 4 power nx plus 4 power n 4 power n delta m is same as phi of 4 power n nx, because 4 power n delta m is an even integer when n greater than m. That means this will imply gamma n is 0 for all n greater than m. Right? So gamma n is 0 for all n greater than m. Now, when 0 less equal to n less equal to m, okay, 0 less equal to n less equal to n, on this case gamma n less equal to 4 power n, because we can see phi s mod of phi s minus phi t is less equal to mod of s minus t for any real number st. That is quite obvious, right? Because phi s is basically mod x and I am just periodically extend it. So mod of phi s minus mod of phi s minus phi t is always less equal to mod of s minus t, because the function is itself mod x type, right? You can just check that. It's easy to take, right? So that means mod of phi of 4 power nx plus 4 power n delta m minus phi of 4 power nx by delta m, this is less equal to 4 power n delta m divided by delta m, which is 4 power n. That means gamma n mod gamma n less equal to 4 power n, right? Now if n equal to m, that means 4 power n delta m equal to 4 power m delta m, which is same equal to plus minus half, right? Okay, so phi of 4 power mx plus 4 power m delta m minus phi of 4 power mx, okay, this is mod by delta m is basically given by, so this part is given by half, and this is delta m, which is same as half by, sorry, it is mod half 4 power minus m, which is equal to 4 power m. Okay, that means mod of gamma n is 4 power m. Now mod of f of x plus delta m minus f of x by delta m is equal to mod of summation n equal to 0 to infinity 3 by 4 power n phi of what is the definition? 4 power nx, right? Phi of 4 power nx plus 4 power n delta m minus summation n equal to 0 to infinity 3 by 4 or n phi of 4 power nx by mod of delta m. But we already know that for m greater than for n greater than m, this term is 0, right? This term is 0. So then I can just get this as n equal to 0 to infinity. Let me write one more line so that you can easily get gamma n, okay, because we defined in this way, right? Define that gamma n to be this one, right? So ultimately we have this thing, and for n greater than m, gamma n is 0. That means it is enough to take the sum up to n equal to m 3 by 4 power n gamma n, right? Okay, so that is same as taking 0 to m minus 1 3 by 4 power n gamma n, right? Which is by triangle inequality, which is greater than 3 by 4 power m gamma m minus mod of summation n equal to 0 to m minus 1 3 by 4 power n gamma n. Then what we have, gamma m is 4 power m, right, by definition. So 3 power m minus summation n equal to 0 to m minus 1 3 by 4 power n mod of gamma n, right? Now since for 0 less equal to m less equal to n, gamma n is less equal to 4 power n, okay, then we have this is greater equal to 3 power m minus summation n equal to 0 to m minus 1 3 power n, because mod gamma n is less equal to 4 power n. So that means mod gamma n by 4 power n is less equal to 1. Since this is negative, so that is greater equal to 3 power n times 1. So we get this. Now we have this 3 power m minus 1 plus 3 square up to 3 power m minus 1, which is same as 3 power m, right? I should mention it is equal, right? It's equal minus 3 power m minus 1 by 2, okay? So that is 2 times 3 power m minus 3 power m plus 1 by 2, which is same as 3 power m plus 1 by 2, okay? That means which is strictly greater than half, right? That means mod f of x plus delta m minus fx by delta m is strictly greater than half for all m, right? Now as m tends to infinity, delta m tends to 0, right? Because since delta m equal to plus minus 1 by 2 4 power m, depend on the scenario, depend on x. Okay, so that means ultimately it tends to 0. So that means by sequential criteria of differentiability, it is not differentiable at x, and you can do the same thing for any x. Okay, I hope this is clear. If you have any doubt, please comment. It's a nice question.